thank you for joining this webinar. 10 in Orlando and myself in Vienna, Austria, want to show you the news of terrestrial laser scanning after the week of the Intergeo in Essen, Germany. So I hope you enjoy the next half an hour. At the beginning, there is the brand new laser scanner RIEGL VZ-i 600i, and I want to show you how we improved our VZ-i laser scanner family. And with this scanner, it's also possible to increase the ranging precision. I'll tell you how. And also some ongoing terrestrial laser scanning developments. Afterwards, 10 hands over and take the new kinematic app for VZ-i series laser scanners. We will show that. Also the new export features for RISCAN Pro and RIProcess, and the API of the Ripano software for the integration of the third-party solution. Let's start with a video. So if the bandwidth is not good enough, you see there is a link to, our YouTube channel. You can download this video, which shows the high productivity of the laser scanner with up to 60 scan positions per hour, half a minute real scanning time, lightweight, only 6 kilograms, and yeah, it's very flexible and prepared also for the future with a ROS driver, robot operating system, 3 internal cameras. So I hope you want to see all these news. We made a very first project in Austria. So you can see a house scanned with more than 160 scan positions in 2.5 hours, X-ray view, internal and external. And then we had another project in the center of Vienna. It's the Wienfluss, where we took, I think, more than 200 scan positions above the ground and underground. To check the instrument, and 2 of these prototypes were at the exhibition last week at the Intergeo. You saw also the project map app. You can see in the field how all these scan positions are registered in the field. There are a lot of applications, and we want to go into depth right now. One of the most important questions is, why the VZ-i laser scanners? We have a second processor inside of the scanner, which is a high performance processor, and it's integrated. So the integrated second processor, that's the reason for the VZ-i series. So the last years we had the VZ400i, and there is a standard that one operator takes, in this case, 380 scan positions in 1 day. That was the Volkstheater in Vienna. You see on the left the colored points for each scan positions. Another project is the small house, a rather small house with 160 scan positions. You see the VZ-i series app for remote control. That's on the left app, and the right one is the project map app, where you can see the scan data and the registered scan positions in the field. Let's go to the start. The first laser scanner was called LMS Z210, introduced 1998 by Dr. RIEGL and Dr. Ulrich. 2008, we introduced the VZ400, and 2015, the VZ400i. So then the question, what's about the new scanner? Before we start to develop a new scanner, we have to think about technical specification and the requests of the customer. So what's the technical specification? You can see our data sheets with a lot of numbers about the weight, the speed, the accuracy, the range, if the scanner has the robot operating system driver, or what kind of field of view. In other words, what's about the versatility, the performance, the productivity, the future mobility. On the other side, there are also the customer's application, building information modeling, construction, robotic, tunnel surveying, vegetation measurements, and so on. So, and we have to also have a look to our strengths. So the VZ400i is really strong in range, in the speed of up to 50 scan positions, and the onboard registration is very unique and very robust. But what's about the customer request? So we listen to our customer, we ask, so what do you want? And the number one was less weight. And all the others, so more field of view, faster, higher accuracy, integrated RGB cameras, a higher scan resolution, even a longer maximum measurement range. I want to discuss step by step. Less weight. What does it mean? There is a consequence. We have to use a light and durable material for that scanner. And the second is we say goodbye to the cylindrical shape of the laser scanner. Because of the flat circuit boards, we have to have a cuboid shape. What's about the field of view and the speed of the laser scanner? So why do we need more field of view? Because if you want to have a full dome scanner, you want to scan the room, the space above the scanner. And the reason for the higher speed is the higher productivity. That's clear. But there is one problem. These both requirements contradict each other. What does it mean? Do you really need a full dome scan to scan the ceiling? Perhaps it's not right, except for vertical shafts. Why? If you look to the scan here on the right side, you see there is no gap on the ceiling. And why? It's because there are so many scan positions taken outdoor and indoor of this house. So if you close the gaps underneath the tripod, you close the gaps on the ceiling. With another picture, so we have a hole above the scanner and also a shadow behind the lamp. And with a second scan position in the same room, we can close the gap to eliminate all the scan shadows. Now let's talk about the speed. The field of view of the VZ400i is 100 degrees times 360 degrees, and the full dome scanner is closed on the top. Now we have to have a look to the mirror on the left side. So the VZ400i is using a multifaceted mirror, and a full dome scanner has to have a rotating mirror, a single rotating mirror. If we rotate both of them with 100 rotations per second, which is quite fast, or the maximum which is possible, then we have on the left side 400 lines per second, on the right side 200 lines. That means on the left side with a multifaceted mirror, we are much faster, so by the factor of 2, than on the right side. So our decision was for the left side. We go for the faster laser scanner. What's the speed of a laser scanner? It's not only the pulse repetition rate, both a high pulse repetition rate and a high scanning rate. I showed you now the scanning rate. Both together gives a really high speed terrestrial laser scanner. And perhaps it's a better definition if you say the speed of a terrestrial laser scanner is the maximum number of scans per hour or scan positions per hour. everyone wants to have a higher accuracy. So if you check our data sheets, now we have a 3D position accuracy of 3 millimeter in 50 meter distance, so which is better than in the past. And we want to improve ourselves even in the next years. About the high precision, I will tell you a little bit later. Laser beam divergent, if you compare different laser beam divergent, so it's the question of the definition. So if you have 0.25 milliradian on the left side, it's the same like 0.35 milliradian, but please check the footnotes. The RGB camera has to be integrated. Yes, that's right, that's good, we did it. But better is we have two options. Either you have the integrated RGB cameras or the external system camera for low light conditions. Everyone want to have a higher scan resolution. So in the past, we had a Panorama 40, a standard scan pattern, which means we had a spatial resolution of 7 millimeters in 10 meter distance. So we changed now to the standard scan of 6 millimeter resolution in 10 meter distance. We do not call it Panorama 34 millidegree. We call it now Panorama 6 millimeter. So it's easier to understand that the scan pattern is connected to the resolution in 10 meter distance. Longer maximum measurement range, not really for our laser scanners, because we keep different measurement programs, so you can choose more or less the maximum range as you like. As longer you want to scan, as slower is the pulse repetition rate. So some years ago we said, okay, we need a 4-facet mirror laser scanner. We take the pulse repetition rate of 2.2 megahertz instead of 1.2 megahertz with the VC400i and 2000i. And the standard scan pattern will be 6 millimeter resolution, 10 meter distance, which is the same like 34 millidegree angular resolution. Out of these numbers, you can calculate the MTA zone, multiple time around, which is now 68 meters. And we have a good feature to solve these problems with the MTA zones. And then, yeah, what is the required line scan speed? And we need to have 416 lines per second. And then we will achieve a scan time of unbelievable 25 seconds per scan with 6 millimeter resolution. So we started the development, and the result is the VC600i. And if we go to the specs, you can see the 2.2 kilohertz with a maximum range of up to 1 to 200 meters. And if you choose another measurement rate, the scanner goes several hundred meters maximum range. The minimum range is half a meter, and for that 2.2 megahertz, we have up to 5 targets per pulse, which is a multiple pulse instrument, multiple target instrument. The ranging accuracy is 5 millimeter. The 3D positioning accuracy is 3 millimeter at 50 meters. And the precision is 3 millimeter, 1 millimeter or better with extended scan time, which I'll show you afterwards. What's about the performance? I told you 30 seconds for the Panorama 6 millimeter scan. That means that you can achieve up to 60 scan positions per hour. If it's not fast enough for you, then you can reduce the resolution. For example, if you use a 5 centimeter resolution, 10 meter distance, then we have a 2-second scan time. The 6 millimeter resolution has a 25-second scanning time. So on the left side, you see the scan for the 5 centimeter resolution. On the right side, the 6 millimeter resolution. There is an integrated L1 GNSS receiver, and there is an option for an external RIEGL GNSS RTK receiver, which can be mounted on top. The data storage is again a 1 terabyte SSD hard drive, but then we have a SF Express card with 0.5 terabyte, and the speed of that is 5 times higher than the LAN cable. There are 3 cameras integrated, each 12 megapixel, to cover the full field of view. You can take pictures after the scan or while scanning, with both. With the external camera, which is optional on top, it's a Sony Alpha 7R4, or with the internal cameras. The weight of the scanner without batteries is less than 6 kilograms. Each battery, there are 2 rechargeable batteries which you can enter into the instrument, has each 0.5 kilogram, and it takes about 1 hour and 20 minutes. The protection class is IP64, dust and splash proof. If you check the QR code on the left side, you jump into the VZ600i data sheet, which is already online. And new is the accessory list of this scanner, which gives you the full list of all the accessories. Here you can see the GNSS antenna, the RTK GNSS antenna with or without external camera, the rechargeable batteries with a charger for 2 or for 6 batteries. Both can be operated also from a car, 12 volt. The example project was a house in Austria in September. Scanning time 2.5 hours for the whole project. 164 scan positions. That means about 55 scans per scan position. So that means we can achieve this 60 scans per hour, which means every minute a scan position. The one-touch processing wizard, I think you know it already. A different task to convert, filter, and register the scan positions. There is a fine adjustment with a multi-station adjustment. We can calibrate the mounting calibration for the external camera, colorize the point cloud. We can eliminate the moving targets and generate octree-based point clouds. At the end, you get a full detailed PDF report. In this case, it was finished after 4 hours, only by pressing one touch on the key, and there is no manual work to do. The result here is the point cloud with or without the color. And the application for the VZ600i is building information modeling, so the survey and as-built survey, road survey and mapping, so for the oil and gas industry, the facility design and construction, design build, monitoring build, and documentation of the progress, engineering and infrastructure, heritage documentation, also for the forestry, for research, and for forensic. So we call it high productivity, high performance, versatility, and future proofing. On the right side, you see again the onboard registration. So no mobile device is necessary for that, but you can use it to display it and to orientate yourself in the field. So if you see all these different features, the most important are the real-time onboard registration, which is absolutely unique because so robust. It's working with and without GNSS, with and without light. Then the 30-second scan times, it's really top of the market with a 6mm resolution, 360-degree scan. And with a 6-kilogram lightweight instrument, it's really fun to work in the field. How to increase the range precision? So if you take a look onto our specification sheets, you will find one line for ranging precision with 2 footnotes with some more explanation what precision is. It's a repeatability or the range noise. We specify for our terrestrial laser scanners 3 millimeters. There are different factors affecting the actual range noise or precision of such a measurement. The ranging precision is directly influenced by the target reflectivity and the target range. There are also influences by the angular resolution, the acquisition time, which is correlated with the measurement rate, and the scanning speed. Let's have a look to the new VZ-600i laser scanner. It will only need about half a minute, as I told you before, for the panorama 6mm scan. Other instruments on the market takes about 2 to 3 minutes for such a panorama scan. The question is now, can we trading a longer scan time and even a little bit less maximum range for a higher precision? I show you some test data from the VZ-600i. We have an office cabinet here where we took some data at a range of about 8.5 meters. With a fast scan, just 30 seconds, 6mm resolution at 10 meters, we will end up with a range noise of just a little bit more than 1 millimeter. If we take data in about 2.5 minutes, we can achieve much lower range noise by making use of some averaging features. The answer would be yes, we can trade in a longer scan time for higher precision. Now we come to the ongoing developments in terrestrial laser scanning. So if you see the house and all the scan positions on the right side with a ground-based laser scan, you see also there is a scan shadow on top. So I have the personal feeling that we should use in the future the terrestrial scans with airborne photographs, which are taken by a drone. So there are drones on the market with only 249 grams, which is very important for Europe, for the European law, because there is no license necessary to fly. Of course, there you have to have an insurance and so on. It has a 48 megapixel camera, and you can fly above this house, for example. And with the software reality capture, which is about 3,000 euros, you can combine the terrestrial scans with the airborne photographs in order to close the gap on top. Another topic is the RTK position accuracy can be combined with the RIEGL VZ-i RTK receiver. In the past, you have to change a file inside of the scanner. Now we changed in the newest firmware, we changed the graphic user interface, so you can enter the correction the data for the service company for the correction for the RTK GNSS receiver. There is also a service company called Premium Positioning. You see on the right side the coverage on the Earth, and with this company you can get for this first 6 months a free correction signal to check out how does it work with your VZI laser scanner. It works with the VZ400i, 2000i, and of course with the VZ600i, but with the newest firmware. We developed a ROS driver, robot operating system driver, and we are busy with some R&D project. On the left side, it's Mobilize to combine the terrestrial scanner with RGB cameras, infrared cameras, and even microphone arrays. And all these sensors are working together with ROS, with the robot operating system. On the right side, you see another project. Many sensors are mounted on a robot, and also here they are working together with this robot operating system, and I think we will see many applications in the future because it's so easy to integrate a new sensor. We even have our own ROS robot. It's called RIEGL VMR. Actually, there are two ROS systems. One is the laser scanner with the on-top camera and the vehicle. And then there is another one with only the 4 cameras in the middle, in this case 4 Sony Alpha 7 R3 cameras and the LED lights. So this should show how to combine 2 ROS systems, and for the end customer, how he can integrate his own sensors by himself. Each ROS system has its own power supply and its own computer. I think the ROS robot will have a good future because we can solve their problems, the robotic industry problem about ground truth. I'm talking here about the stop and go scanning. Here we have a video of that VMR at the test drive. There were some reflectors close to the rail, and before you start, you give the list of the reflectors to the robot, and it will stand still in this case, every 7 meters. In between, it makes also a stop only for the cameras. That was a test drive, and the next step is that we go into the subway area or into the tunnels, so we can make use of the 4 cameras with the LED light, and then we can combine the laser scan data with the images. Again, in the field, you see the project map app and all the registered scan positions. That's a robot. You press only once the button, and then it will do everything by itself. 1 or 2 operators can dismount the complete system, put it into a normal car, and is very flexible to drive to the next project. So the first result is a colored point cloud. But if you think about the tunnel applications and so on, we combine, you see it on the right down, the reality capture again. We combine the high resolution photographs with the point cloud. And if you have a closer look, then you see the resolution of the data, which is unbelievable. So thank you for your attention, and I hand over to Tan, please.
Thank you, Nikolaus, for that excellent presentation and introduction of the VZ600i. Wow, what a great year for, exciting year for TLS division here at RIEGL. Not only we have a new scanner for the market, which is smaller, compact, versatile. Their specs is absolutely incredible, right? Whenever I first saw it too as well. But not only we have different new scanners, we also have new tools and functionality for not only for the new scanner, the 600i, but also for our existing customer VZ400i series, which you can see here in the content, the new kinematic app for VZ-i series laser scanners, and also new exporting tools, which will allow us to combine photogrammetry with laser in a tile format so that we could bring it into a third-party software, and then also a new API integration for third-party software in our viewer right panel. Yeah, so this presentation is supposed to go on for 30 minutes, but since there's nothing after us, so please allow me to extend this even further. Yeah. So let's begin with the kinematic function. So in the past, we've used a VZ200i or a VZ400i, or even the non-I series combined with a VMZ. But with the new developments of making use of the internal IMU, we can then utilize our expertise in creating a trajectory combined with the raw data and also the RTK information. We can really turn this thing into a a kinematic mobile scanner. Now, please, of course, don't take this as a replacement for any mobile scanner. This is just an additional tools that to show you the expand capability of our I series scanners. So, of course, the cost for all these tools can range from very high and to very low, right? So we can see here a laser scan, or sorry, an RTK itself has a minimum cost, but then when you look at a laser scanner, it has a very high cost. In the IMU in the scanner, this is going to be a low cost, but then combine it all with both hardware and all three parts, we can then make this thing a kinematic 3D laser scanning system. Let's take a little bit deeper to see how we are processing and acquiring data from the scanner. Now, of course, the scanner is, the versatility is really wide. You can see here is an image collecting data directly from a motorcraft, right? So I can see an application for this where if you're doing hydrographic surveying, you can mount this on top of a boat while you're collecting data underneath the water. You can also collect data above the water too as well. Now, please understand that this this tool requires real-time RTK the entire time. You can have RTK directly from a VRS network once you get your scanner online, or you could, with the I series now, from my understanding, you can integrate a external GPS such as a Trimble, Leica, or even such as a different name brand manufacturers, and you can get a direct correction from a base network, or again, you can get it from a VRS network. Now, other type of vehicles that I've seen this thing goes on is such as a bicycle here that our colleagues did a demonstration on, or you can put it on an ATV or on top of a vehicle and drive slow. Of course, please do not mistake this as a full mobile system that you can drive up to high speed, right? So on the back of the scanner, on the app page, you can see that there is a new kinematic app. This app could be implemented through a firmware update and also a app install too as well. Please reach out to us for availability, but you can see you simply click on the kinematic app, you create a project. This system can be used in two different modes. One in radar mode as the instruments continue to scan, or in line mode where you can set a fixed angle and then the line mirror will just spin, and then as you're driving down, you would then create your 3D model. You can set your frequency, your range, and also your rotation scan speed too as well. And the workflow as goes, you just start a static scan. Once that static scan is done, you initialize the mobile scan, and as you're moving down the road or moving down across down the sidewalk on a bicycle, you then create your 3D model, and then you stop the project, and then you process the data as follows. So we have done some research with a university that can process kinematic in a traditional way, which you combine GNSS and IMU, the raw data, to create an initial trajectory. And once that's created, step 2 is when you initialize the georeference of the data. So once you combine the GNSS raw data with the IMU raw data, you can then georeference the LiDAR data. And then from there, you do a strip adjustment, which then improves and modify the trajectory. And then part 4, you then just finalize the point cloud by reapplying the correct trajectory to the LiDAR data by improving it and such. And then, of course, you get a final point cloud. Now, to take it even further in the RIEGL processing, we do the same first 2 steps. We combine the raw IMU data with the GNSS raw data, and then you create a trajectory. Then you initialize, then you apply the georeferencing data georeferencing the LiDAR data. But more importantly, by recalculating the trajectory from the IMU raw data and also the GNSS position, along with the additional highly accurate data from the laser scanner, you can then improve your trajectory drastically, therefore creating a much more improved accurate trajectory point cloud. And we'll show you that here shortly too as well. And so forth, we just take the last 2 same steps as follow. Now, here's an example project that our colleagues did. And back in June, they acquired approximately 1.5 kilometer of road in an urban setting. It took them about 7+ hours to do, acquiring up to 310 scan positions, moving 10 meters apart. Now, of course, on a traditional tripod method, this is a very fast and very accurate and very precise way to acquire data in a stop-and-go fashion. But of course, when we did the test along using a bicycle going down the same path, 1.5 kilometer equals to about almost a mile. You can see the time has reduced greatly down to just 7 minutes. Now that's riding down both directions, so you have 2 paths down the same street, so that's about a factor of 20, right? So you can see the time it takes on a terrestrial scanning and the time it takes to do it in a mobile kinematic fashion. Now let's look at the results. So you can see here, this is the initial processing chain that a traditional processing chain. You can see the point cloud is quite fuzzy. We just then again calculate the GNSS raw data along with the IMU raw data, and then apply the georeferencing to the data, and then doing a script to correct the data. But RIEGL has taken a step further inside of our process software, which is done in RISCAN Pro 2 as well. We can then correct the data and reduce the fuzziness by utilizing the accurate 3D laser scanning data from the I-Series scanner. Here is an image of the same road that the data was acquired on. Here's the point cloud, colorized point cloud from the stop and go back in June. And here is just a reflectance point cloud, not colorized. And here is the point cloud from the kinematic data. Now you can see the data is very sparse. This depends on the speed that you're traveling it at. It's quite sparse, but that's not the test here. But if we do a sample of a cross section, compare. So this is a top view of that section that we just did across on. You can see the terrestrial data stop and go is very clean, very accurate, very low noise level. But of course, when we compare it with the mobile data, this is the traditional processing way, not the accurate LiDAR has not been applied to the processing. You can see the range noise is 0.25 meters plus and minus, but when we apply and correct, we have, and of course, most of that error comes from the integrated IMU. We have to look at a couple of factors before we can really determine the accuracy and precision of the kinematic data, right? So what are some of the factors, right? What's some of the dominating error when creating this trajectory? One, with the VZ-i series, we have a very low-grade IMU. Of course, with a dedicated mobile system, we have a very high-grade IMU. And then, of course, the short-term noise is very high on the kinematic side of a laser scanner. And then we have a huge yaw error also as well in the I-series kinematic system. But when we correct it with, when we include the highly accurate LiDAR data from the I-series scanner, we can then improve our trajectory quite well and then reapply the georeference data to the point cloud. Therefore, the result is quite amazing before and after our correction with the LiDAR data. Here's just another example compared. So you can see here with the corrected data, it's quite good. So the 0.05 has gone down to 0.05, which is just 5 centimeters. Here you can also look at it from a tall structure too as well. So we have near and far range and also vertical height too as well that we can acquire kinematic data too. Okay. Here's a perfect example of the traditional processing of the IMU raw data and correction, but when you plus the LiDAR data trajectory processing, you can see the differences is quite dramatic. Okay. Now let's take it a little bit. Now let's change gear a little bit. Now we're going to get into our software updates. First, I want to make sure that everybody understands that we only support Windows 10 now and higher. We shouldn't be using Windows 7 anyways. And the new release for RISCAN Pro 2.116 is in the near future. I suspect it to release sometime very, very soon. But within the new software, we're able to do a couple new things. For example, exporting new exporting wizard to allow us to include imagery and also bringing cross-reference data into RIProcess and RIProcess into RISCAN Pro for data fusion, right? So we're making that merge to be more streamlined and to be a more dedicated workflow as so. Yeah, so you can look here, you can see RISCAN Pro. We have first simply select a coordinate system, which you can go from WGS84 down to NAT83, down to UTM. It does not matter. You just create the database inside GeoSystem Manager. And once you have the database, you select it. And then you choose your format. You can go from LES to LAZ. And then, of course, RDB, which is a RIEGL database format too as well. And then more importantly, you can structure the output. You can tile and set your parameters and attributes on such large projects, right? So you don't have to export such large project. You can create ship files, and then just categorize the area of interest and apply the tiles to the data set that you want to export, and then you can export just those areas. And then you can apply filter to it too as well, such as the point attributes, deviation filters, reflectance filter, point classification, all the filters you can utilize inside RISCAN Pro. You can apply it prior to exporting it to RIProcess for data fusion or whatever need is necessary. Here, you can also use the wizard too as well. So you start out with a naming convention. And then you can then tile your area. On the right-hand side, you can see a fine example of what a tile looks like and a colorized index. And then each tile is then linked to whatever scan positions that, however you want to tile it to. It's quite simple. It's quite intuitive, and it's a good way to export a large data set in a tiling format. Here's also different parameters that you can use, such as you want just a limited range, so you don't have to export all the range from each position or each kinematic data. You can export a limited range or a range gate. I'm sorry. Yep. And then the last thing I want to show you is the automated point cloud export. So this export allowed us to combine different features and attributes during the export using a tool that we implemented about a year ago called RIEGL, which has a Python scripting so that you can implement the input, the output, the location, and the attributes, and a simple naming convention. And if you are an expert in Python, you can do it through the scripting file, or you can just simply use the wizard. Okay. And then now I want to talk about, this is the wizard. It's all the same attributes. You just set your position. You want to set your segmentation so you don't have to export all the point cloud, your segment, which is your tiles, and then all the tiles belongs to each segment, and then you just follow the steps and just export the individual and Octree, of course, all the filters and implemented during this export too as well. Okay. And then the last thing I want to talk about exporting. So in the past, we've had some, this function was not available. But now we recently modified and redid the exporting format for bringing the images into a third-party software, and this pertains to large images and also a small amount of images too as well. So you can see this picture here with the VMR base, which houses additional cameras for bringing it into third-party software such as Topodot. So now each images or in sections, we can export it georeference in a format that third-party software such as Topodot can accept. Of course, each images tells the file name, position, and also the orientation, which is all described in the exporting wizard. Okay. And then last but not least, I want to introduce some new development for RIEGL. So recently, RIEGL is just a simple export that's created inside of RISCAN Pro, which allows the user to view and host the data on a tablet or a computer, which the viewer can then open it on a web browser if it's properly hosted from a server, right? But we're taking it a little bit further, where we implemented a third-party software integration using our API, which then the customer can customize the appearances and functionality of the viewing program, such as changing logos and making use of their own markers and distances and path. They can really tailor the RIEGL panel through the API and have it how they want it to look in their own special platform. And you can see here, this is an example that you can see the user here, the company has its own software viewing platform, which is an online platform. He can then set a username, password, duration of the viewing time. So, you know, if you're a client, I give you 50 days to view it. Here's your login, here's your user password, and that expires, right? And then within that software, they can do a number of things like I just mentioned earlier. They can, make special tools and use their own special tools inside the software as you wish. You can delete markers, you can add markers and such, right? Just moving along the development of our viewer for the future. You can see here, you can also locate it on a map too as well worldwide. So if you're scanning projects on a different location all over the world, and you want it marked on a map, you certainly can too as well. And here's just a project of a substation with many scan position. Again, the background is from our right panel, but with an API, our users can then make it their own viewer capability. And I think that's it. So thank you for your attention. And I think we are open to questions.
So I got two questions. One was how many scans on average out of the 2 batteries? And I sent my answer to everyone. So each battery lasts about 1 hour, 20 minutes. And each minute we take a scan. It was a panorama, 6 millimeter, not 4 millimeter, 6 millimeter panorama every minute. That means up to 160 scans with the scan positions with the 2 batteries. That's with the movement of the tripod. The next question was, are the panoramic images full dome? Unfortunately, no, sorry, at present not. We are working on a solution with a on top mounted small panoramic camera. We expect it until the end of the year, so we can trigger it. Everything is fine. We are working on the camera calibration. There is a tricky question about, we recently bought a VZ-400i to the mangrove forest in South Florida, but we couldn't get RTK correction serve as no internet. Any suggestions if we want accurate GPS position for our scanner? Is from Mr. Lin Xiong. So please, Tan, I hope you know the email address. I will forward to my colleague who is specialist for forestry and for GNSS. So I have no answer right now.
Yeah, it is quite difficult to get a signal. So it depends on what type of RTK you're using. If you're using an external RTK, you might have a better, higher probability because you're then using a base station and RTK where you're getting a radio signal correction instead of a satellite correction. So I'm not sure exactly which RTK you're using, but typically in those conditions, a radio correction from a rover to base is a better method.
So for the VZ-400i, I'm sure that the connection to the RIEGL base station is working with a long range connection. So there is, but I think we should answer this by email. So export data from reprocess to software orbit. I'm sorry, I have to ask my colleague if it's from reprocess, because reprocess is for kinematic scanning, and I don't know that answer. Can you show the battery charge? Sorry, I cannot open it. I cannot read the full. Can you read the full question, please? Can you show the battery charge? So perhaps it's the battery charger. So that's the small one for the 2 batteries. Here we have the battery itself. So it's very small. And the other one is the 6, the box for the 6. And there is one position for transport and one position to charge the batteries. But I really cannot read the full question. I don't know, it's too small for me. Can you show the battery charge unit, please? So I did it. About the For the VZ-i series, what is the maximum speed for operation? Yeah, I don't know.
It's really hard to say, because the faster you go, of course, the wider the line speed is going to be, right? I've done some testing on top of a vehicle, which we were traveling up to just 10 miles per hour and less, and I pushed it around on a wheel tripod, which we're traveling maybe just 2 or 3 miles per hour. But until we do further testing, and unless you want to as well, it's really hard to say. But again, this doesn't replace a mobile scanner where we're driving down a road. This is just for unique application that you can use it for.
So I just ordered a VZ400i. Was it a mistake? We can deliver the first VZ600i in first quarter of the next year. So unfortunately, we do not get the polygonal mirror in time right now. But even the VZ400i and the VZ2000i will stay on the market. So we have a family from 400i, 600i, and 2000i. It's depending on the application you need.
It's definitely not a mistake. And Nikolaus is right. We cannot, delivery time is expected to be in Q1 of 2023. But nevertheless, this new kinematic tool, it's for our previous I series and also the 600i. So even users that recently purchased a 400i can benefit from this new kinematic tool, which I've used it and it looks absolutely amazing. So you have to consider that delivery time and also cost too as well. And then, hi guys, congratulations. Can you provide a maximum and minimum operation temperature? Nikolaus, a customer wants to know the maximum and minimum operations temperature.
Yeah, I give you soon. If you go to the RIEGL website, give me a second. I give you soon the answer. But the second part of the question is, additionally, can someone create a custom interface on the device in so much as it would be just removing options and buttons for basic users? So if you operate the scanner, you will see there is really only one single button. So you move the scanner from one scan position to the next, and you press only one single button. In the future, we also will shut down the screen if you don't need it, and you can press the button of the scanner, this one. So it's really to press one single button. I think it's really easy. Unfortunately, it's not possible to remove anything out of the GUI. And yeah, I don't know if this answer is good enough for you. I really don't know I want to give you the if you go to our website, Terrestrial Scanner, and then you have the new data sheet, and then you go to the data sheet for the VZ600i, then you can see there is minus 10 degrees Celsius up to plus 50 is for storage, and for operations is 0 degrees Celsius up to plus 40 degrees Celsius. So that's online, and you can check it by yourself.
Now, from my understanding, I've had some questions about the kinematic app. That I suspect will be introduced later on this year, before the end of the year. It's not quite ready yet, and it won't be ready until the new release of RISE-CAM Pro anyways. So even if you did have the kinematic app now, you won't be able to process the data unless you had new RISE-CAM Pro. So you can see those two kind of being at the same time.
So there is the question, using our VZ400i in a mobile configuration will be fantastic, as there been much talk about indoor mobile scanning options with georeferenced targets. That kind of mobile scanning, which was shown by 10, needs a good GNSS receiver, RTK. So we did not talk about indoor mobile scanning. So no solution yet. I don't know about the future. Nobody knows. And yes, of course, we work also on that. So
and also at the moment, oh, sorry.
So that okay, sorry. Please give the answer to Mr. Kylie O'Brien. That's about the indoor mobile scanning.
Oh, yeah. I'm sure that's a future development. I'm not sure. No way I would know. But I also want to remind you that the imagery, nobody has asked about that. There's also currently no imagery too as well on the 400i. So right now it's just the LiDAR data being collected, but that can also change in the future too as well.
Okay, so sorry if I spell it in the wrong way. Mr. Johan Erasmus asked for the charger. I can show it again. That's the box for the 6 batteries. It looks like that. I'm sorry, I have to check my screen. So it looks like that. And there are 2, either in this direction or in this direction, or vertical or a horizontal. So in one, you can transport the batteries, for example, in the airplane, because it's not connected to anything. And on the other, in the other direction, you can charge it, either with a.
One customer wants you to take it off the tripod and show it close. Nikolaus, is that possible?
Yeah, I don't know about my. Can you see it? So can you see how lightweight it is? I cannot do that with another scanner.
That's true.
And then there is a quick action. So I only take it like this, and then it's like here. And we also forget sometimes to see the hand grip, which allows you also to carry the scanner on a ladder or something like that. So what is about the projected cost of the VZ600i? Yeah, of course. Thank you for the question. That means you are interested. I cannot give you the costs right now. Next week, I hope we have the list price. It's higher than the 400i, of course, especially in the time where everything is more expensive. I don't know about the American market, but I hope next week we get a list price. Could you take the scanner behind you off the tripod and show closer? Thanks. Does the VZ600 use the same battery? I cannot see the whole as a 400i. That's an interesting question. Outside, it's not the same, so you cannot use the same battery in both instruments. But inside, it's very similar, and we tried also to charge the old batteries with a new charger, but please give us a little bit time to adapt it also to the VZ400i batteries. It takes some time. And I think that was
Yeah, I think that's all the time we have for Nikolaus. Thank you for everybody's attention. And yeah, please visit us online. Contact your local dealer. I mean, the region that you're purchasing the system from, and we'll give you all the information you need. Okay, and if you have any additional question, please send us an email, and we look forward to some more webinars on our new topics, new scanners, new software, hardware, and yeah, and if there's something you guys want to see us present or me present, some more additional training stuff, let me know, and we'll be happy to get it going.